You know when you're in an exam and you're thinking, what do they actually want me to write here? Well, today we're going to answer that. We're taking one big 14-mark GCSE chemistry question. And we're not just going to answer it, we're going to break it down using the official mark scheme, the examiner's playbook really, to make sure we can bag every single point.
All right, so here it is, question 4. And yeah, it's a big one. It's based on a practical, so you've got a graph, you've got calculations, you've got explanations, the whole shebang. 14 marks. I mean, that's a massive chunk of your paper, right? It could literally be the difference between one grade and the next. So let's treat this like a mission. We're going in and we are coming out with all 14 marks.
So, what's the game plan? First, we'll decode that graph. Then, we'll get into the nitty-gritty of the experimental details. After that, we are going to nail the equations and calculations. And to finish, we'll pack it all up into your very own exam toolkit. Sound good? Let's get into it.
Okay, first things first. Let's tackle this graph. Sometimes graphical questions can feel a bit intimidating, but honestly, think of them as just a story being told with points and lines. The real key is knowing exactly what the examiners are looking for when you read that story.
So right out of the gate, the first task for a cool 2 marks is to draw 2 lines of best fit. Sounds easy enough, but hang on, where do you even draw them? Which points are you supposed to use to make sure you get those marks? And here's the secret, straight from the horse's mouth, the mark scheme. It's not just any 2 random lines. The first mark is for a perfect straight line of best fit that goes through those first 5 points where the temperature is rising. The second mark is for another straight line through the last 4 points where things have flattened out. See? It's not a guessing game at all. You do that and boom, 2 marks are in the bag. Easy.
All right, lines are on the page. Now for the heavy hitter, the 4-mark explanation. A 4-marker means the examiner has a checklist and they are looking for 4 specific correct points. So, how do we build that perfect answer and make sure we give them exactly what they want? We do it 1 marking point at a time.
Marking point number 1 is all about the core science. Why is the temperature shooting up? You've got to state that the reaction is exothermic. Simple as that. It's releasing energy or transferring it to the surroundings, and that's why things are heating up. That's your first tick in the box.
Now, for the second point, and this is crucial, you have to pull a number from your graph. The temperature keeps rising until it hits that turning point where your lines cross. You need to pinpoint exactly where that is. According to the mark scheme, that magic number is 0.8 grams of zinc. You have to write down that specific value to get the mark.
Okay, so the temperature rise stops. But why? That's what the third mark is for. You just have to connect the dots and state the obvious consequence. Well, the reaction has stopped. No more reaction means no more heat being produced. It's a simple cause and effect that shows you understand what's happening.
And for the final killer point, you have to explain the science behind why the reaction packed it in. You need to show you understand what a limiting reactant is. So you can either say the copper sulfate got all used up, or, looking at it the other way, the zinc is now in excess. Say either of those, and that's your 4th and final mark. Job done. Okay, so we've totally nailed the results. But what about how the experiment was actually done? Let's switch gears and look at the method itself, because the next set of marks is all about understanding the why behind the setup.
So, question 4.3. Why on earth use a flimsy polystyrene cup instead of a proper glass beaker? It's a classic question, and the mark scheme is looking for a 2-part answer. First, you get a mark for saying polystyrene is a better thermal insulator. But you can't stop there. For the second point, you have to explain what that means. It means less energy or heat is lost to the surroundings. Simple.
Okay, this next bit is a proper insider tip. Question 4.6 asks for a source of random error. Now, a lot of students write down the first thing that pops into their head, but let's look at what an examiner is actually allowed to give you a mark for. So here's the official list. They'll accept things like the starting temperature might be different each time, or inconsistent stirring. They'll even allow inconsistent use of a lid. But check this out. The extra info says they will ignore a mention of room temperature. This is gold. So many people write that, but it's just too vague for the examiners. You gotta be more specific. All right, section 3, time for the numbers and symbols. This is where being neat and precise really pays off. Getting the details right is everything.
Okay, 4.4, the ionic equation. To get the full 2 marks here, every little detail has to be perfect. You've got your solid zinc, right? That's Zn with a little s.
It's reacting with copper ions, which are floating around in a solution, so that's Cu2+ with an AQ, and that makes zinc ions, which are also in solution, Zn2+ AQ, and solid copper, Cus. Get all those parts, including the state symbols, and the marks are yours.
Let's move on to the calculation in 4.5. They give you this table with 4 different temperature readings from 4 trials. Your job is to find 2 things from this data, the mean, which is just the average, and the uncertainty. Let's do it.
It's actually pretty straightforward if you follow the steps. Step 1, just add all 4 of those temperature values up. You get 150.0. Step 2, take that total and divide by 4 to get the mean, which is 37.5 degrees Celsius. Step 3, for the uncertainty, find the range. So take the biggest number, 37.8, and subtract the smallest, 37.2, which gives you 0.6. Then you just chop that range in half to get your uncertainty, plus or minus 0.3.
And listen, this is super important. To get all 3 marks available here, you can't just write down the numbers anywhere. The format is everything. Your final answer has to be laid out exactly like this: 37.5 degrees Celsius plus or minus 0.3 degrees Celsius. Presenting it this way shows you've done every part of the calculation correct. And that is it. We have done it. We have hunted down and captured all 14 of those marks. So for our last section, let's just step back and look at the awesome set of skills we've just put into practice. I mean, just look at this toolkit you've built. In just this one question, we've practiced how to plot and interpret lines of best fit, how to explain trends in exothermic reactions, critique the experimental method, write a perfect ionic equation, calculate a mean and uncertainty, and even identify valid random errors. These aren't just for this one question. This stuff comes up all over the paper.
So, you see? This wasn't just about learning the answers to question 4. It was about learning how to think like an examiner, how to break down these big, meaty questions, and how to give them exactly what they're looking for. You've seen the method. The only question now is, which of these skills are you going to go and master next?